From LaGrange, Illinois, comes the experimental Aerotrain, representing GM's new concept in railroading.
In the 1950s, the General Electric Aerotrain was envisioned as a futuristic marvel for travel from New York to Chicago, yet it faced a paradox in reality. You see, despite its sleek appearance, the journey on board this train was miserable, marked by uncomfortable noises and shakiness, consequences of ambitious ideas colliding with technological limitations of the time. In an era where trains dominated long-range travel, the Aerotrain attempted to redefine transportation. Though flawed, its lasting legacy has influenced subsequent developments in train technology and highlighted the inconvenient crossroads of aspiration versus reality. So join me to discover why it failed and what remains as we discover the history of the Aerotrain. I'm your host, Ryan Socash, and you're watching It's History. Train routes from New York to Chicago first opened in 1853, providing for the westward expansion of the United States as people relocated to the sparsely populated areas of the West. After that, trains gradually got bigger, faster, and eventually more luxurious as people began to travel for pleasure and business. However, these trends would not last forever, and in the decades to follow, as people were able to buy cars and intercity travel was open to the air, innovation became more necessary than ever. By the 50s, the once thriving industry needed to change or it would face permanent damages. So, to return to profitability, it was decided trains needed to balance lightweight design and fuel efficiency with passenger comfort and speed. Qualities that turn out to be very difficult to achieve in the form of a train. General Motors Vice President of Styling, Harley Earl, took the initiative to the company's electromotive division and lead designer, Chuck Jordan. To Earl, this opportunity to fill the gap in the market and reinvigorate their locomotive design and sales was obvious, so the project had to get ahead quickly. However, while Jordan was an experienced and MIT-educated engineer, this should have been taken as something of a first warning sign. You see, Jordan had worked with General Motors since 1948 and had previously designed the popular Chevy Cameo carrier pickup truck. However, with only a few years in the company and no previous experience in railway engineering, he might not have been the best choice for lead designer. And it wasn't that General Motors didn't have bureaus and designers that could have handled this mission better. They previously had massive success selling their E and F model trains. So from what I can tell, Jordan must have been sent to the project for his perceived value in styling of now popular family and personal vehicles. Nevertheless, he and his team set to work on designing a more aerodynamic and fuel-efficient train. The official designation would eventually be the LW12 or Lightweight 1200 horsepower train. The engine itself was a fairly reliable 567C 12-cylinder prime mover, which was included in other models, but this one was more optimized for efficiency. It was originally advertised as the Y-Train in a 1955 issue of Look magazine, which celebrated cruise speeds higher than 100 miles per hour and crossings from New York to Chicago in just 10.5 hours. But this was all before a test model was displayed as the Pennsy Aerotrain the next year. For the bodywork, well, that's where this goes from practical to unique. The Aerotrain was, as implied by the name, supposed to be more aerodynamic. And from a modern perspective, this is quite obvious. We probably think of European trains with curved or teardrop front and rear ends of the vehicle, or the Japanese bullet trains with long noses like a Formula One race car. And while for many reasons, those designs wouldn't be common or practical for about 3 decades, the Aerotrain's interpretation of this is unique. The engine car honestly looks like a passenger jet fuselage sandwiched between a regular train chassis and the top of a Buick LeSabre, which was Jordan's favorite day-to-day vehicle. Rather than having a front or mid-driver's cab, the cab instead sat like a regular day car on top of the engine with a full frontal windscreen and styled windows. And although I think the train looked beautiful, the public's perception was not so positive. The train had 10 carriages for passengers, counting the observation carriage. Once again, General Motors and Jordan took an unconventional design approach, and the carriages were modeled off of transit buses from GM's motor division. It seemed weird, even at the time, for the train to style itself like its rival in intercity travel, but there was a practicality to it. The 40 feet long carriages were half the length and weight of the other train cars of the day. To improve efficiency by removing the need for a baggage car, passengers had storage compartments at the bottom of each carriage for their luggage. The observation car even appeared to have a vertical taillight like a family Suburban. This weight saving and cost cutting meant that GM could advertise through pamphlets and sales brochures that the operational price per ticket would get cut in half, and that the need to constantly repair damaged carriages would just be undone by the ability to buy new ones straight from the company with the same ease as Greyhound replacing a broken bus. And to be fair, in theory, all of these advantages potentially could have given GM a solid product that could have helped them stem the bleeding from the national rail services. Yet, instead of the anticipated boom in sales and tickets, General Motors would be met with silence. On January the 5th, 1956, the first Aerotrain was tested on the run from Washington, D.C. to Newark by the Pennsylvania Railroad Company. The other train ran from Chicago to Detroit, and the trains did make good time, with the Chicago-Detroit route being accomplished in approximately 4 hours. And the Pennsylvania service would move one of their trains to the regular DC Newark route on February the 6th. However, astonishingly, it was withdrawn the next day. That February, after some adjustments, the Pennsylvania company put the train back to work on the New York-Pittsburgh route, renting the Aerotrain for just $250 a day for an expected 7.5-hour ride, which indeed was record-breaking, as that target would be the fastest that this particular route would ever be accomplished. The other train was demonstrated across the intercity routes in the Midwest, Southern Pacific, and Union Pacific routes, but all of the customers pretty much had the same reaction. They were unimpressed with the train, and they demonstrated their lack of enthusiasm by not buying tickets. In turn, train companies refused to further lease the train, and the few that were left online had serious issues with speed. Even so, eventually in April, it was put to service on the Chicago-Detroit route, remaining the fastest train for that route by about 40 minutes. But again, these routes didn't persist. On the East Coast, the Aerotrain was relegated to just the Philadelphia-Pittsburgh line in June. Then, from July, the train running from Union Pacific was relocated to Chicago-Cleveland, before moving yet again to Los Angeles-Las Vegas in December. One upside was that the fares were cheap, around $17 for a round trip, and the ride would even include free food in the chuck wagon car. The number 2 train was eventually joined by its sister before all operations using the Aerotrain were suspended and the prototype engines were directly returned to GM. By now they had been tested across some of the major rail lines in the country, and unfortunately the verdict on their performance was unanimously abysmal. The Union Pacific and Pennsylvania railroads both agreed that whether the trains were on short or long routes, the trains just didn't work. At anywhere near their top speed, the combination of bus-style carriages, lightweight frames, and a poorly integrated air suspension system meant the passengers were simply miserable. One rider recalls that anywhere near that 100 miles per hour speed target, and the ride would, quote, almost beat the passengers to death, while the noise in the carriages also became unbearable. That quotation sounds like an exaggeration, but even so, it doesn't sound like an environment anyone would want to spend time in. And while the train could reach its speed goals on a good day, in general, it was also underpowered. In fact, the trains required the help of a cargo diesel locomotive to move through the steep canyon pass for the first time. All these aspects, these failures at every level, showed in ticket sales. The Union Pacific Aerotrain never carried a full passenger load once on its LA to Vegas route, even after several months of operating. In one article, it was even said that the train of the future rode like an old truck. No major rail company wanted one, and so it was. Both trains would end up being sold to Rock Island Railroad for low-speed commuter service at a heavy discount in 1957. They were finally retired for the last time in 1966. Their potential as groundbreakers for new, cheap, reliable, and fast rail transit never came to be. Innovations like their bus-style cabins for easy replacement were never used, and they maintained the same passenger carriages they were shipped to Pennsylvania and Union Pacific with in 1956. The design was a complete failure, so the next question has to be why. The answer is honestly pretty simple. Trains need to be designed to meet 4 criteria: speed, comfort, lightweight, and low operating cost, or good utility value. The Aerotrain failed because it just wasn't comfortable. It was underpowered and overcomplicated. That General Motors team, as led by Harley Earl, took an opening they saw in the market and sought to create an innovative product for it. In theory, it was a good business, but in practice, they moved too quickly. Ultimately, the Aerotrain was nothing more than a previous engine and carriage system put together under a stylish body design. To GM, it sounded like enough because the individual components were already proven. The passenger carriages would work because they were basically buses. The engine would work because it was already widely used. The suspension would also work because that as well was being used. Aluminum hulls would work because they were cheap, lightweight material that looked beautiful. But what GM missed was that none of these aspects were successfully working together. Nobody used them together, and General Motors didn't test them together. The fact is, for research and production of a new, efficient, high-speed train system to work, years of development are needed. Sure, it doesn't pay off instantly, but it can assure customer satisfaction. That's the same for trains, cars, trucks, ships, and airplanes. Out of all the businesses in the world, you'd think that a company as massive as General Motors would have embraced that notion. Somehow they didn't, and this attitude of rapid innovation without experimentation would start to cost the company dearly through the 60s. Thankfully for them, the Aerotrain debacle happened quietly, without many people other than train enthusiasts and market watchers seeing it. Other poor designs and bodywork decisions, such as the Chevy Corvair, X-Cars, and later on the Pontiac Phoenix and Buick Skylark in the 80s, well, they would not enjoy that same luxury. The Aerotrain may have ended its passenger runs in 1966, but thankfully that wasn't the end of it altogether. While the train itself was a disaster, people did admire its style. It created an image from afar of a jet skimming along the ground, stylishly dragging a trail of passengers from city to city behind it. Closer, it created an image of hybridization as the carriages mirrored the Greyhound buses moving people around America. Even amongst other attempts at high-speed trains, it is iconic and unique. So that's why I'm glad to say that while most of the cars were scrapped, as they had been in pretty bad shape by 1966, both of the trains themselves survived. Train number 2 is in the National Railroad Museum in Green Bay, while engine number 1 and 2 of the passenger cars are at the National Museum of Transportation in St. Louis. For all of their faults, it is good to know that both of them survive to tell their story somehow, even if that story is a warning to other businesses to avoid becoming a train out of control. And we'll leave it there for today, but I thank you all for watching. I hope you'll consider subscribing and visiting our members area. Otherwise, until next time, I'm Ryan Sokash, signing off.